Record. And ladies and gentlemen, welcome back to Make It Happen. I'm Brent Siebold, and I'm proud to welcome Dean from our Herberger Institute for Design and the Arts. He teaches industrial design, but more importantly, he's an innovator, and he can help all of us establish a competitive advantage when it comes to our career and building new products, building new services, and building things ultimately that people want. And that's the holy grail of innovation. So Dean, without further ado, we just had a great round robin. We met, looks like about 10 or 15 aspiring innovators and change makers have joined us here. They've got nothing better to do than to hear from you. So let's hear about it.
Well, hey, welcome everybody. This is great. This is actually really pretty great turnout from being online and all. So let's get started. I'm going to, Brent, can you allow me to share the screen?
Oh, I'm sorry, Dean. I didn't realize that I did not give you that ability. So there you go.
All right.
Zoom is really cracking down these days on security, so should have full access.
All right. Let me see where I am here. Oh, here we go.
All right, looks good. We can see all your slides. If you want to go to presenter view.
All right, so in the, if you guys want to chat and write down any questions, you know, as I'm writing or as I'm talking, that's always kind of the best thing so that you don't forget and just kind of keep a running tally of what's going on. So I will talk today about, let me watch my time, leveraging industrial design in new product ventures. So it's kind of a long title, but really it's an introduction to industrial design and what industrial design can do to assist new product development. And it can be your own startup, or it can also be used within your company that you're working at. So this is me, Dean Picasso, and these are some things that I've actually led product teams on. So I've done footwear, specifically high performance running footwear, very high performance bicycles, and then some camping gear. So those were some actual things that I worked on and brought to market, and have been doing that for the past 20 years now. So I want to start off with some shots from Indiegogo and Kickstarter and just some crowdfunding to show you what's available for you as inventors, as innovators, and starting a company through crowdfunding. So these are some through Indiegogo, and you can see the one on the right, the Baby Maker Stealth Road e-bike with a belt drive has garnered $8 million to start their company. A couple other ones, and these are the popular projects, and you can see easily 1 million, over $1 million for a lot of these. So if you have an idea is one thing. We're going to talk about that, and then as you say, to create a need for it or to create a want, and to sell that into the market or to have it pulled into the market is another thing entirely. Here's another one, another kick scooter, but still upwards of $200,000, only 288 backers. So that's doing pretty well. Here's another one, and this is for eating and proportion control and things like that. And again, another one that has a great start to a company of nearly $2 million. As young inventors, this is oftentimes what we do is we will go on to these crowdfunding sites and poke around and see what is trending. And so that's part of your research. You may have this really, really wonderful idea, only to discover that it was it was put out into the market 6 months ago. And so now how do you product differentiate yours from somebody else's, right? So here's the $1,000,000 question, right? Is how do you go from A to B? How do you go from current state of the art to creating state of the art? Right? How do you go from just an idea to something that you sell, something that is mass produced in the thousands, right? Not 500, not 50, right? You all can probably make 50 devices in your garage. But when you start to make 500 or 5,000 or 50,000, that is where the magic happens. And that is also where the problems happen, right? So just imagine if you make 50, somebody returns one, you can take it back and fix it and make it better. But if you have 50,000 pieces out there and 500 come back, then you're starting to run into some difficulty. So how do we get there from A to B? Well, it is a really, really messy process. And you have to be willing to dig into that bowl of spaghetti and somehow come out the very end with something that a consumer wants, the market wants, at a reasonable price. Right? So to work in the world of product development is you have to be able to deal with a lot of changes. You have to be able to be pulled in a lot of directions, make some really good decisions based on what you've researched. There are so many, many, many people that are involved with product design, product development. And you can see anywhere from industrial design to purchasing, product management, quality control, shipping, right? Even if you make a couple in your garage, you have to pack it up, put a label on it, have somebody pick it up, or maybe you walk it over to the US Postal and then you send it. So all that is not trivial, right? Because you may have a lot in shipping costs. All right, but I think one of the most important things to do is really to understand what industrial design is and how industrial design can be leveraged throughout the entire process. It's not just on the front end. So if you were to type into Dr. Google industrial design, you would probably see a bunch of these type of images. And this is pretty exciting stuff. This is pretty fun things to work on. And it's usually front end, right? Everybody likes that front end, kind of playing around, brainstorming. But industrial design can be pulled all the way through the end, and you'll see how. So industrial design, a lot of sketching, some foam carving, some color exploration, things like that. If you look at these three elements, form, aesthetics, how does it look? Engineering, how does it work? Will it break? Human factors, how do people use it? Industrial design ideally fits in the middle of those three. Right? Now, years ago, industrial design was kind of relegated, kind of stuck in aesthetics. So if you wanted something to look great, you would hire an industrial designer. Well, industrial design has evolved, and so industrial designers start to get involved with these questions. Right? So how does it work? How did you design it? How is it assembled? And industrial design can help along with assembly line work because we're always looking for human factors and ergonomics, not just the product itself, but how people would assemble it. If you look at how things look or how does it look, you can see it online for sure, but if you have a retail space where it's sold is how does that product pull somebody into to turn that box around? Like that's all part of industrial design. How does it feel? There's a trick, right? When in retail, you pick it up and it feels great. And you pull the trigger or you do something with it, and you're like, oh, great, I'll buy it. But when you start to use it for 20 minutes or an hour and you have to store it someplace, that is also part of where industrial design can help your product development, give you a little bit of an edge. All right, so I'll go through some really quick images of what industrial design, or how industrial design touches products. So a little bit of high tech, right, with some camera gimbals, some low tech, static things, right? You look at each of these, and the high tech, right, it has to be easy to put on. It has to be easy to adjust. That's where industrial design can help. We work on small objects, we work on large objects. We work on things that are external, also internal. So if you look at that car on the right, or that concept car on the right by Audi, is certainly the aesthetics was probably play modeled, but once you get inside, right, the seating, the layout of the control panel, the layout of the controls, right, industrial design has a hand in that as well. You have some toys, right? But then you have some very high-tech toys. So if you look at the controller on the right, is, industrial design will look at how efficient somebody uses a controller and where they might be able to design the interface. Right? If you're typically playing a game, you're not looking at your controllers, and so you should be able to feel those details. We also do soft goods and hard goods. Look at that tent on the left. Soft goods, right? Sewing, packing down, storage, weatherproofing. And then you look at the image on the right, some high-tech products over there. It's high-tech materials, different material usage over there. Human factors, not just UI, UX, right? Not just digital interface, but physical interfaces. So the image on the left is a Formula One racing car, and you can see all those crazy dials and buttons, and they have different colors and placements. And you'll see there are a lot of case studies where people have accidents because they're assuming that a button does something or it doesn't do something. So you can push it, or you can pull it, or you can turn it and twist it, right? Industrial design is all about that as well. We are also involved in space design. So if you look at the image on the left, that is at a trade show. And so the image, and actually my cousin works in exhibit design, he talks about the company's mojo. So when he designs a space, when people walk in there, there's a certain feel, kind of a certain vibe they get when they walk in there, and it's different. Right, Nintendo is very different than Microsoft, right? Xbox, which is very different than PlayStation. Right, so you have to capture that mojo, and you have to capture it from the customer perspective. We also do a lot of concept art. So another direction is purely concept art. It's not real yet, but it's dreaming. It's a little bit things that will be in 10 years or 15 years. So that's a bit of a breakdown of what industrial designers do as far as physical-wise. And now the very tricky part, very, very tricky part is designing for people. And there's universal design. So when you look at designing for people, right, many of you are under 30. So when you design for a 30-year-old, I'm over 50. Right, so when I look at an object, I can't see certain things. I have to blow up the text. I have to pull things away from me so I can see things. You look at people in wheelchairs, right? There's a height difference. So industrial design starts to incorporate all of that into the design, into the product design. So how do we get there? Right? This is what we started with in the beginning. Well, you have to start somewhere. You have to understand the problem, of course. You have to understand the users. You have to understand the market. And then you get into this really, really fun process where you fail, you make things, you draw things, you share it, you fail, people don't like it, you change it, and then you solve more problems. Right? And so this evolution, you can see these 4 intermediate prototypes, 1, 2, 3, 4. They each have a small change to it, small iteration. And if you're not willing to share, if you're not willing to show your idea to somebody, you will never improve it until you get it into the market. And then if you get it into the market, your user might say, oh, well, I would never use that because of something. Right? So as soon as you have an idea, share it with somebody. It's very difficult to take somebody's idea and bring it into market, as you will soon see. All right, so research is understanding the user. So these images are really just saying, go talk to people. You are not, as a designer or an engineer, you are not the end user. We see things that people will never see. Engineers will see things that nobody cares about, right? The user doesn't care that you're using certain gears, right? All they care about is pressing that button and what the end effect, right? So you have to kind of get that out of your head, right? The technology doesn't sell your product so much as the user experience does. So you have to understand the user. Start talking to people. There's lots of methods that we can talk about. We did some brainstorming last time of ways to open up your mind and share those kind of nutty ideas. And you have to start with a sketch, right? And typically designers would go through maybe 50 to 100 sketches before it starts to formulate. If you're not sketching 50, you're not understanding the problem. My cousin used to be the creative director at Disney, and she said that their managers, their creative team, would demand 100 sketches. Because what happens is the first 25, you're trying to understand. You're just figuring out what the problem is. From 25 to 75 is where the magic happens. You understand it, you're starting to figure things out, and then 75 to 100 is when you start repeating things because you're starting to exhaust your creativity. And so if you don't do that front end and back end, right, you'll never get to that kind of juicy middle part. So these sketches here are just one of many, many pages worth. So got to sketch something, and then you have to make something. Right? We can talk about it all day long, but until you put it in somebody's hand, right, how big it is, until you let them put it into their backpack, until you let them put it on their desk so that they can see how it lives, right? A lot of students will design things for a bedside table, but there's all kinds of things on a bedside table. It's never empty, right? There might be a lamp, there could be books, there could be glasses, there could be drinking glasses, right? And so you have to design for that environment. So in industrial design, we do some really, really quick prototypes. A lot of times they're out of paper or cardboard. The image on the left is foam. So you'll start to carve some foam. You can just use blue foam, insulation foam from your house and just start carving something. It doesn't need to be aluminum. You don't need to do CNC. Right? Just put something into somebody's hands and start to role play. So you have to do some sketches. You have to make some quick models. And then once things start to kind of come to a point, start to funnel down, then you can really start to work on aesthetics. So this bicycle on the left, I was part of that team when I was at a bicycle company in California. And the lead designer made this out of foam. So he did have some steel underneath it to give it structure, but he put foam on and just carved around it. And you have to test it, right? You have to get people to test the controls. So that bicycle on the right is an electric bicycle. Most of the time, it's being charged. Right? Most of the time, it's in somebody's garage. Most of the time, it's locked up at a bike rack. Right? And so, as industrial designers, we look at that full life cycle, not just the product use, right? but the maintenance of, the repair, the storage, right? That's what industrial designers will bring to the table for you. And of course, what we do is all about people. And so we understand human factors, we go through charts. Now I know that engineers also have human factors engineering, which is fantastic, right? They look at things differently than the way industrial designers look at it. So industrial designers will certainly measure things, but we're looking at if somebody's doing a repetitive motion and then they rub their arm like this, that's what we're trying to figure out. Why are they rubbing their arm, right? Where an engineer might be measuring pinch force to assemble something, right? So they're similar, but they're very different in that, again, industrial design always brings in the user. All right, so how can we leverage industrial design into the process? So now that you know a little bit about what we do, let's see what we do. Here's a guideline. Whenever your product is touched by a human being, that's where you need to bring in industrial design. That's a big claim, right? Because somebody's always touching something, and that's where industrial design can help. We just see things a little bit differently. It's not to say that engineers and business people can't learn to see what we see, but that's how we are educated, right? To see the human condition. All right, so if we look at footwear, right, I was also a designer of footwear. The end user, right, is the person who's walking, right? So in the lower left-hand corner, those are the end users. But there are the factory people that have to put it together. In the right, that's Phil Knight. When he was starting Nike, he had to sell those shoes, right? So when I was designing shoes, I would often contact the retailer and say, hey, how can I help you sell more shoes, right? And then in the lower right-hand corner is the back end, right? If you really love a pair of shoes, you can get them repaired. And so how can I, as a designer, use materials that a cobbler can use? And so wherever that product touches somebody, or somebody touches that product, bring in industrial design. All right, I'm going to zip through this. So industrial design is this kind of what we follow when we're designing a product to be sold. And we use the ASU innovation model. And the first thing that we look at, well, there's 5 of them, right? So 1, 2, 3, 4, 5. I'm only going to talk to you about value to the stakeholders and then desirability by the market. Okay, so value to the stakeholders, which are people, desirable by the market, which are people. So that's kind of what I want to talk about, is how people play into this whole game. All right? Any questions so far? 12:40, I'm going to zip through this so we can have a chat session after. So, value to stakeholders, right? This is a big topic, right? Making face shields. So Oakley is now jumping in. And if we look at the stakeholders, usually go through 3 stakeholder levels, right? You have the primary level, which are the healthcare and first responders. Now these might change depending on how you look at this. Your secondary are the hospitals, right? They have to buy it. They have to store it. They have to distribute it. And so that's why they're very important to this process, right? If this face shield if you can only store it in this round shape, it takes up a lot of space, right? But if you can flatten it, then you can stick a lot more into under a desk. So secondary would be your hospitals, maybe your factory assembly. Your tertiary would be the maintenance and possibly the suppliers. So maintenance, can this be used after? And then how easy is it for somebody to unsnap it, wipe it clean, and then reattach it, right? Generally, the nurses or the doctors won't do that, right? They may, but they may not. So you look at some more stakeholders. So I'm gonna dive in even more to understanding. If we look at healthcare, right? On the left are your nurses, In the middle is your surgeon, who now is attaching things to the face shield, or he's wearing, loops to look closer, right? And then if you look to the right, now you look at healthcare that was brought outside. So this face shield, if it's used inside or outside, could make a big difference. So maybe if you use it outside, they tint it a little bit. I don't know, I'm guessing here, right? So even though you have a primary stakeholder, even within that now becomes a very special case of observing how people use it, right? So again, people outside, maybe there's a little bit of a drizzle. It's hot outside. Maybe it's going to fog up that shield. Right? Where inside, it's more of a controlled environment. So what kind of material are you using? How can you clean it? Can you snap off, right? So dig into that user, and you will be light years ahead of other companies. All right. Good ideas or marketable idea? So is it a good idea or marketable idea? Meaning your friends and family say, oh, that's a really good idea. Where investors will say, that's a marketable idea, and I can sell that. So what I like about this image here is that out of 1, 2, 3, 4, out of 5 ideas, right, 4 are trash that you throw out, and 1 is good. And those are the ones that you pursue. All right, so good idea or marketable idea? 1, does it satisfy a user need? So the inventor of the pet rock made millions of dollars back in the 70s or so when it was invented, and it was a rock in a box, right? At that time, there was a need, and the pricing was probably right. Number 2, what are people doing right now, right, that satisfies the need? So if you need a pet, you can have a pet rock, or you can have a goldfish, you can have a lizard, you can have a dog, right? What are people doing right now? What makes yours different than just a fish bowl, right? So it's basically a fish bowl, but it's connected, it's elevated, it's a little bit more interesting to look at, it's a little bit more interesting to walk around. Each one of those globes could be a different environment, right? So you can have this, or you can have this. And then what is the user willing to pay for that, right? So that's the other thing. Cost is always an important factor, right? So 1, 2, 3. Is there added value to this? So this is really cool, right? It's difficult to clean. You have to go in there and scrub it every now and again, just kind of drop stuff in there. Is there added value to this?
Yes.
How many of you out there would buy something like that? All right, so 5 different kind of guidelines to follow, whether it's a good idea or a marketable idea. So we all hear this word innovation, right? Innovation for whom? So who are we innovating for? Remember this. This is so important for you as an inventor, you as a creator, you as a designer engineer, right? We are not the end user. Right? Remember that. We know too much. We spent way too many hours on this, right? We know how it works. We know how it doesn't work. So here's some examples. This is an elevator panel. I don't know who approved this, but it just doesn't make sense, right? You don't, I take that back. It makes a little bit of sense, right? Because we read left to right. So I don't know if there was an issue with trying to save space or what was happening. Maybe they had a mirror above it, right? But this was what I would call a product fail. Another one. Don't just add things on for users, right? Think smart about these. It'd be fun to ride a bike down, but It'd be hard to pull somebody up in a wheelchair. Anybody know the story about the 2015 Grand Cherokee and how it killed an actor? There was an actor from Star Trek that had this particular car, and this is all about user interface. This is a really, really great idea. That control, the automatic transmission control, but it was too different from what we already know. And so what happened was the design team or the engineering team or the creative team who created the one on the left thought that it would be great that controller is always in the same place. But what they forgot was, right, all those years of using the one on the right, we associate park and safety with being forward. Right? We associate drive with being backwards. So the one on the left always stayed in the middle, and so the actor who got killed thought that that car was in drive when actually was in neutral. And so he went down behind the car, and the car ran him over, or trapped him between a wall. So innovation isn't always that great, right? You have to always keep innovation with the user. What do they know? What do we know, right? All right, here's some very, very common warning labels on the left, right? It's pretty comical. So think really hard about this. Do not use while sleeping. Why would they put that on you? I grew up in Chicago, and during the winter times, people would leave their ovens on and open the oven door. So I'm guessing that somebody tried to use this while they were sleeping to stay warm, and something caught fire. Right? And so if we're industrial designers understanding the user, we could talk to the engineering team and say, hey, put in a sensor for overheating. This person is going to put it underneath a blanket. What kind of sensor technology do we have that would protect it from causing fire? What kind of material could we use that it doesn't burn? Right? Understanding the user. The one on the right is, I'm in the bike business, right? Or was in the bicycle business. So all those labels right there are a result of people getting hurt very badly. Wear a helmet, we know that. Right? Make sure your stem and pedals are tight. We've seen this before where people are jumping around and the pedal breaks off and they get hurt. Do not ride at night. This was a really, really big lawsuit back in the 80s where somebody was riding their bike with reflectors and they thought that a car could see them because they had reflectors. And so he got seriously injured. He was a college student and he made lots of money, but I think he was paralyzed from the neck down. Read owner's manual. Who out there is going to read an owner's manual to ride a bike, right? That's kind of the fallback for being safe. All right, Brent, I'm going to do a really quick plug for this course I'm teaching in the summer. It's a 590 course. It's called Foundation Industrial Design Seminar, and it's really for people who are interested in learning more about industrial design. It's designed for graduate students, but I'm allowing really anybody to come in there and learn about industrial design, opportunities for industrial designers, tools that we use, fundamental skills, and really since it's for new graduate students, it's how to navigate design school or graduate school. And it starts up next week. So
Fantastic.
That's me.
So much, Dean.
Yeah, you're welcome. If anybody has any questions, you can email me there. I'm usually pretty good about getting back within a couple hours. So that's me.
Great. Well, as always, really compelling examples and interesting methods and very thought-provoking consequences. As you explained there, obviously the consequence of buying a toilet with a fish tank is not immediately clear, but obviously with the kind of the human condition and general human behavior, death is a possible outcome, as you described. So it's really
Yes.
important stuff. And so I did hear you referenced the chat. I'm not sure if you saw Jonathan asked a question specific. Did you get a chance to respond to that? I did have to step away, I think, for a quick second. I wasn't exactly sure if you saw.
No, I
Jonathan.
didn't. I didn't see the chat. So let me read through that really quick.
Yeah, so Jonathan, feel free to unmute yourself and chime in if you'd like to provide a little bit of context to your question for Dean.
Yeah, Dean. So
Mhm.
as a mechanical engineer, especially going through ASU's program, we learn more about the function and practicality of a design, of a beam and how it loads.
Right.
But as the industrial designer, as I'm out in the marketplace designing my own products, there was no, I guess, fundamental of the customer acceptance. Like you're saying, how does it feel after 15 minutes? That concept in mechanical engineering was never really talked about. So I'm just trying to, I guess, learn more about industrial design, and maybe as that a career to help as a mechanical to just combine the two.
Yeah, yeah. There's my undergraduate is also in mechanical engineering, so it was difficult to go from that functional kind of mindset, right? Making sure that it performs well, it's lightweight. Um, but within design, we also have this question of, does form follow function, or does function follow form, right? So when you have something like a mouse, like this, the form itself tells you how to grab it, right? It tells you how to use it. But you can also work it the other way, right? Where you kind of, you don't necessarily force people into using something in a certain way, but it helps to guide them in that way. So the form is a result of the way it works, or how you might use it. So it's a great complementary skill, right? As you already alluded to, is paying attention to what the user says. So this is very common. I work with engineers all the time. So an engineer will show me a product and they say, "Hey, isn't this really cool? It's great." And I'll say, "Don't tell me how to use it. I'm just going to use it." And I'll try and grab it and reach out, and they'll say, "No, no, no, that's not the way." And I'll say, "Hey, this is I just bought this. I want to use it on my own." And so each time I try and do something, the engineer will say, "No, no, stop. That's not the way you're supposed to use it." Right? And so that's kind of the just what we fall into as creative people, right? When we are so close to the product, is that we forget that there are people that just can pick something up and try and use it, right? So think, now this is a question for everybody. If you're trying to hammer a nail into the wall, what's the first tool you grab? Stapler? A shoe? Right? How many of you actually go out to the garage and get a hammer?
I do.
I grab a level.
There you go, right? So that's kind of that thinking, right? Is no one's going to use the manual right away. Learn how it works. Does that kind of answer your question, Jonathan?
It does, and thank you. Yeah, it just helped me kind of figure out what I want to do for the next few years or in life is create, which seems to be more in this industrial design aspect.
It's a great skill to have. You just you start to put things into people's hands, and you can see how the form changes.
I think, Jonathan, you're also in a really unique position to kind of ask this question and have perhaps your livelihood ride on the answer. And it reminds me of what Dean started out by saying, engineers, Dean, I'm going to misquote you here, so you might want to restate this, but engineers answer the question, how it works or does it work? What's the rest of that quote? Fill that in, because I think what Jonathan needs to do is figure out, as he's building new products and services, how does he balance those various mindsets through that process?
Yeah, the first thing I would say is once you have an idea or a sketch, show it to somebody and trust their opinion, trust their perspective, right? It's as a male, right? When we design things for women, right? We make some really strange assumptions. We just make it smaller, right? But that's not always the case. And so really just go out into the world and share it and listen to those people.
That's good advice, Dean. Sorry, for my own edification, can you tell me that? So engineers make it work. What was that you said right at the beginning? Engineers can make it work. Designers make it look good, and
right.
Business people do something else. I don't know what business people do.
Yeah, there were the three. One was form or aesthetics. The other one was engineering, how it works. And then the other one was human factors, is how does it feel?
Oh, I see. Okay.
Yeah.
Okay.
Can I make a comment?
Yes, please, John.
Yeah, Dean, I really appreciate your presentation. It's great. My career, I've been out of the working business for a while, but I started my career at 23 years old, driving a $1 trillion submarine, and there's nothing like it. I mean, there's no way to explain what the feeling is driving something that can go from 0 to 15,000 horsepower in about 30 seconds. But I really fell in love with big things. I wanted to work on something that was big, and I've always done that. So, like in a submarine, for example, or a power plant, or a chemical plant, or something, there's so much engineering involved that you can't really have a product design engineer work on everything. There's just no way. And I think that engineers, electrical, mechanical, need to think about some of the things that Dean said. Don't say, oh, well, I'm just going to go get myself a product engineer. You need to think about that while you're designing the beam. Maybe a beam is going to be, in concrete or whatever, but if you're designing a switch, for example, if you're an electrical switch, it's going to go on a control board. We had a lady one time had long fingernails. Switch had a cover on it, so you couldn't accidentally push the button. She put her finger down into the cylinder to push the button, and her fingernail got caught in the button. So this is just an electrical engineer designing a switch. Now, you're not going to bring in a product designer to do that work, but engineers need to have that concept. I've found most of the things that I've done later in my career was root cause analysis, failure analysis, forensic analysis. And there's always down there at the bottom of almost, I'd say 50% plus, were problems that an engineer just didn't understand what Dean just told us that you should focus on when you're designing a product. It's just an observation for everybody. So if you think about that, file some of the stuff that Dean mentioned away, and carry it through your career, you're going to be really well off. Even if you're not an innovator, if you're just a plain old engineer, you really need to have a little bit of sense of what the end user is going to have to face with this thing. Just a comment.
Yeah, great comment. John, I will reach out to you, have you come to my class once.
Anytime.
If you'd be willing to talk about kind of the controls and things like that you see in the submarines.
Yeah, submarines, power plants.
Yeah.
Yeah.
Great.
Hi, I was just wondering whether is there like some sort of a book that you could recommend to a beginner in industrial design?
What part of it? What part of industrial design are you interested in?
So like an introduction and sort of a compilation, in short, a summary in a way. So that the person reading can like get like a suitable sort of understand most of it without actually
Dean, I think that's your next moneymaker is to be able to write a summary book, cliff notes of industrial design here. And because I'm interested in something similar to that, what are some of the key aspects that you need to understand and keep in mind as the engineers of the group are going through and designing this, the key points and things like that.
Yeah, I'm reading this text right now. It's called the Checklist Manifesto. And I started a text actually a couple years ago for young industrial designers, just kind of a checklist. It was a small little handbook that they could go through. So it might be time to finish.
What is it called?
Well, the Checklist Manifesto is something totally different. But I'll look for a book. I'll look for some text, and then I will pass it on to Brent.
Dean, I've
Add
got
it to your library.
a book that I just finished up. It's called Applied Minds. And it's Applied Minds, and the subtitle is How Engineers Think. But it's really more what Dean talked about today. And it uses a number of case studies and talks about a bunch of different techniques, most of them being exactly aesthetics. Most of a lot of the things you touched on. It's a very, very good book. I really enjoyed it.
I'll have to look that up. I'm putting together my reading list.
Applied Minds.
Great.
Yeah, one more that I'd throw in as well, and John and I were actually chatting about this previously. I had just kind of stumbled across, some of you might remember we talked quite a bit about design thinking as a methodology, which relates closely to what Dean has presented here today. But then I read that there's a couple of folks from Google that have developed a process called design sprints that they argue is more applied process of kind of creating new things that are produced through empathy and human intervention. So anyway, the book is called Design Sprint, I believe, but it's written by a couple of gentlemen from Google. Avico, if you want to check that out, might be a good
I just looked it up.
That's a great text. I use that for my juniors and seniors.
Oh, cool.
Yeah.
Great. Well, so just for the sake of keeping everybody honest here during a Wednesday afternoon, it's 1 o'clock. If Dean's willing, we can hang out and take a couple more questions. But if you have to run, especially if you're at work, if you need to get back, thank you so much for coming. Dean, thank you so much on behalf of everyone for presenting today. Always such a stimulating discussion. So thanks again.
You're very welcome. I can hang out for a little bit.
Great. Any other questions?